English, math, science, and they then go back and work with students and introduce them to computer programming. We have very little programming in our schools in the U.S., in middle school especially. We have 3 main sites. On the site, we also have a site in South Carolina and California. Next slide. All our materials that are available for free, they're on our website here. We have more tutorials that you can use, and also the lesson plans the teachers create are also on our website, and they're organized by discipline and also level. All right, next slide. All right, so then I just want to give a couple of examples with Alice on how it helps make some of the concepts come alive. So next slide. First of all, you're working with 3D objects. You don't have to build them because you have to actually be an artist to build them, and it takes a lot of work. So it comes with this huge library of about 1,000 objects that are already built. And what you focus on is just placing the objects in a world, and then you program the objects. So for example, you can see the objects are very visible. You might teach the dragon how to flap his wings. Okay, so that would be a method you would write. All right, go to the next slide. And here's a video, if you can play that. So this just shows the video. There we go. And it's a little silly video, but essentially you've got a dragon in there, and I wrote a method to teach the dragon how to flap its wings, for example. And it's got a lot of the basic concepts, how to glue objects together, how to move objects around. And it's a silly story, but and talk. Okay. You can have sound, you can have images, the picture in the background is an image. So you learn all this, it's fun, okay? That's the whole point, is we want kids to think computer science is fun. We don't want them thinking computer science is about PowerPoint or keyboarding. That's not computer science. Next slide. Here's another example. You can start this as a video. So there's a timer at the bottom, and there's a score. The red is the score, and so if you start the video, I'm controlling the boat, and I'm trying to get the boat to, every time it goes under, I get a point under an arc, and I'm controlling it, trying to get through to the end. And so what the students are learning is they have to have variables to do the timers and the score. They have to update the variables, and so they're learning about that concept. All right, next slide. And this is not a video, but these are just examples. If you've heard of Aragon, it's a book and a movie. And here's a student project where they created a game that used Aragon. You can see they have timers and scores. All right, next slide. Inheritance. Okay, so in Alice, you can understand inheritance very easily. So What you can do is take the chicken, which is on the right, which comes in Alice already built. You can modify it. You can make it red. You can make it bigger. You can add new functions to it so it knows how to jump, fly, scurry, whatever you want to teach it. And you can add events to it. And then you can take it out and you can save it into, and then you can move it into another world that you can use. But essentially, we call it talented chicken now because it knows much more. And so it's inherited all the properties from the original chicken. Okay, so it's a very visual example of inheritance. All right, next example. You can play a video here too. So this is an example of list. And this is actually my students made this. That's some of the students that worked with me one summer. So this is a list, so you can have the list, everybody in the list do the same thing, or everybody in the list do something one at a time. So here they're all dancing together doing the same moves. We just give one command and everybody in the list does the same thing. Now we're having one at a time do something, but it's list operations that you're learning about, and they're very visual. And again, my students made this, so they put me in the world too. Okay, so apparently I can dance. So you can have a lot of fun with Alice. You can take an object in there and make its head invisible and put your head in there, and now you're in Alice. So students have a lot of fun with it. And yet they're also programming. Okay, next slide. Here's an example of selection sort. So if you play this video, again, this is an array, a very visual array. Here we're shuffling, so for each element in the array one at a time, we're randomly grabbing another element to swap with. So we're doing a random shuffle, and you can very visually see it. Okay, and now we're going to the last position on the right, and we swapped. Okay, so now we're going to switch to selection sort. We're going to find the smallest element, which is here, put it in this first slot. And the next smallest, it goes in the second slot. Next smallest goes in the third slot. So you can very visually see how selection sort works. Okay, next slide. Okay, so those are just a couple of examples of how you can visualize concepts in Alice. All right, and then I'm just going to talk briefly about algorithm animation. If you go to the next slide, there's a lot of algorithm animation out there, all kinds out there, more than I could present, just too much. I will mention algorithms.org, which is a collection of algorithm animations. You can go there, and people have they're rated there also, so it help you decide if you want to use an algorithm animation. There's a lot of tools here, Samba, JSamba. Some of them are scripting languages, like Animal Script. Some you have to download and use. Some are, there's just like students have written an algorithm animation, they put it on the web, so you can just search for algorithm animations now and find a lot of them. And there's also a lot of videos of algorithm animation there now too. So if you go to the next slide, here's an example of how you might use an algorithm animation. So again, it's very important for stopping and pausing, asking the class what they're going to do next. If you just show the animations, you don't really know if students are following or not. And again, they have to be interactive. The students need, or they could also create animations. They could also replay animations from lectures. So these are just some of the ways of using algorithm animations in classes. Okay, next slide. Again, here's a red-black tree animation that I found on the web. If you go next. Okay, but this student must have graduated because it no longer works anymore. And that also happens to a lot of the animations that you find out there. A lot of them are just up there for a short period, and then the links don't work anymore. Okay, next slide. Here's another one I found. I'm not sure I checked if that one was there. It was the last time I checked. This is a red-black tree animation. Those are very helpful because they're so complicated as to how they do the recoloring and the rebalancing of a binary search tree. So it's really helpful to have an animation for that topic. All right, next slide. Tracla 2 is another one that works very nicely with red-black trees, although I went there last night. I was just looking at the website, and they said they discontinued it as of January 1 this year. So it may not work anymore. Next slide. Okay, and then another thing that people are doing now is textbooks, electronic textbooks. OpenDSA is one project that's being done at Virginia Tech. So it's not just putting books online, it's also incorporating algorithm animations into the books or some other way of experimenting with concepts. Runestone Interactive is a book It's more of programming where you can experiment with Python code. So you read about the topic and then you actually type in Python code and try an example. Or they might have code there and you modify it. Also with these electronic books is you can track student progress because they can log in. You can see how many times they've tried a particular problem. You can get a lot of data that way. So that's another thing that's nice about electronic books. So these are coming on now. There's companies too, like say Ante. There's a lot of work going towards electronic textbooks right now. Right, next slide. Okay, so now just a little bit about challenges in designing educational software. So next slide. So in JFlap, one thing that we found is this is an example of an algorithm of DFA to regular expression. And we found the first time we did that, it's a very complicated algorithm. And when you're converting from one step to another, there was a lot of things for people to type in. It was just too tedious. And so the next version that we did, we ended up doing a lot of just showing the answer. You can click on a particular case and see how that case works. I clicked on one case over here, and you can just see where it's highlighted over there. But you don't really want the student typing in all the stuff on the right. Okay, next slide. The other thing is if they're going through an algorithm, at some point they need to, if they're stuck, you don't want them just sitting there. So we have a button that will either tell them if they're complete or what they're missing, or even just to show them the answer is another possibility. Next slide. This is an old slide, but essentially when we were first being told, a lot of people had pop-up windows, and you could get the whole screen full of pop-up windows. It was too many, and that really doesn't happen anymore. Next slide. And again, this is JFlap doesn't have this, but a lot of the animation tools now are putting in pause and checkpoints into their animation so that you're watching the animation and it may stop and pause and ask you a question just so you're understanding what's going on. And also ebooks can incorporate this in there. All right, next slide. And then also think about what kind of things would make the tool more usable. We get a lot of feedback on JFlap over the years. Like the annotations on states was a request, so we added it so that now you can do that. The multiple run window was a request. At some point went back. General, we also tried to make it more general so that it works with lots of different definitions. We have batch processing, so we've tried to do things to help it work with more textbooks and make it more usable by more people. All right, next slide. Okay, also, now how do you name your software? So maybe you're not interested in automa theory, but maybe you're thinking, I'm going to create a tool and I'm going to name it. So what is a good name for a tool? All right, next slide. So here's a tool I created a while ago called Java. I think my students actually named it. And it was for algorithm animation a couple of years ago, where you could, it was a scripting language, and you could do primitives and then create algorithm animations on the web. Now, next slide. Turns out it wasn't such a good name because it's also a Star Wars character. And so what happens is if I Google it to see who's using my tool, next slide, I get a lot of hits that are not for my tool. So I can't really figure out who's using the tool or if anybody ever used it. All right, next slide. So JFlap originally started as Flap many years ago for formal language and automata package. In 1996, Java had come along. We converted it to Java like many people did at that time. They had software. Originally, it was in C++ next Windows. And at the time, I thought that was really kind of dumb. Everybody's adding a J to the front of their tool. So it's the Java version of their tool. But it turns out it was a really good thing because, next slide, it's unique. It's not a word in any language. So now I can Google it, and all the hits, 41,000, are for JFlap, my tool. Because we've actually had students go through and look at all these links, and they're all for my tool, so it's very cool. People have translated it to other languages. They've done all kinds of things with it. All right, next slide. And it's much better than, if you have a good name, unique name, than Google Analytics. So Google Analytics will tell you who's downloaded it, but you're missing a lot of other things if you don't have a unique name. For example, people are blogging about it. So you can see what they're saying about it, or they're asking questions on Stack Overflow. Or they're using it in their courses. It's on their course web pages. So that's what you're going to miss if you're just doing something like analytics. All right, next slide. And I even found that somebody had a workshop on theory of computation at Rajiv Gandhi College of Engineering. Anybody from there? No? Okay. And next slide. And they were using JFlap in a lab session there. So that's what I found by just looking at links last night. Okay. All right, next slide. Okay, and then, so that's a lot of how you can use software to make concepts come alive. And now I just wanted to talk about a couple of other different ways to make concepts come alive. Okay, next slide. All right, so I have a couple of props here. Okay, so we are now going to pass parameters. Don't run. Who wants to catch a frisbee? You can catch frisbee? Okay. All right, we have a frisbee catcher. All right, so we're going to pass a frisbee by reference. Okay, so here's my frisbee. I'm going to throw it to you, or attempt to. And you can see that I'm going to give her the actual frisbee, passed by reference. All right, ready? Oh, very good. Okay, so now she has my variable passed by reference, so she could actually change it. She could be adding, changing the value, whatever she's going to do. And now she's going to throw it back to me. Oh, you can't throw them. You can only catch them, huh? You have to come closer then. Come closer. That works. Okay. All right. Okay, and so she may have changed it when I got it back, okay, because I passed it by reference. Now, what I'm going to demo is I'm going to pass it by value. So in this case, I don't want to give her my original frisbee, so I'm going to give her a copy of my frisbee. Okay, so now she can't change it. Okay, ready? Okay. Whoops, sorry, I missed. Okay. All right, so now I have the original, so she could be changing it, doing whatever she wants to with it. It's not going to matter because I have the original. So that's the difference between pass by reference and pass by value. Okay? All right. Somebody's going to have to help. You get it for me? Okay, thank you. All right. Now, there's one more way if you're doing, say, C++. If you're doing C++, they have something called const reference. Okay, so I'm actually going to give her the, actually, I'll probably throw it to somebody that's closer because I can't throw that far this time. I'm going to put my variable to pass it by const reference. I'm going to put it in a plastic bag because I'm going to throw the original, but I don't want her to change it. So I'm going to put it in this plastic bag to protect it so she can look at the value, but she can't change it. I'm just going to throw it to one of you guys, okay? Because it doesn't fly as well in a plastic bag. Okay, so now they have the original, but they can look at it, but they can't change it because that plastic bag is not openable. And then you pass it back to me. Okay, all right, we got it. Okay, so that's const reference. Okay, so now if you do this with your students, they will remember all three because they're very visual, they're active, and they're paying attention because you're throwing frisbees at them. Okay? Okay. Okay. And you get a J-flat frisbee? You can come get a J-flat frisbee. I can't throw it that far because it's too low, but you can come on up, come on. I'll just put it right here. You can come pick it up. All right. Okay. They're little frisbees. They're harder to throw. Okay. All right. Next slide. Okay. So now, now you would not believe at the airport they had no idea what this was in my bag. It's my memory heap. All right. You gonna be my memory heap? Okay. So I'll give it to you. Come here. So I'm gonna give you my memory heap. You can buy these in toy stores, okay? All right, so now I'm going to build a linked list, and when I need more memory, I'm going to say new to my memory heap, new, and you're going to throw me a node. New, you have to open it. Just pull straight out there. Or you can bring it back and I'll open it for you. There you go, okay. All right, so I will say new, you're going to throw me a node, okay? And I don't know if you can see it, but it even has a little pointer thing on it. Okay. All right. So I've got a node, and so that's what happens. A lot of students forget to say new to get the memory, and they're like, "Why does it not work?" Because you forgot to get the memory. Okay. So now I can say new again, and he'll throw me another node. Okay. All right. We got it. We got it. Okay. Okay. And now I can stick them together. So I inserted that there. Okay. You can see now I have a linked list of new nodes. Okay, and then you can keep going, and every time you say new, you get another node, and you put it in there, and you can build a linked list, You could have values on them and talk about how you're inserting in a linked list or deleting from a linked list. Very visual. Your students will remember. Okay, you can bring it back now. All right, thank you for being my memory heap. Okay, good job. All right. Again, I had to explain to the lady what this thing was in my bag. All right. Okay, next slide. Okay. Okay, so this is another way to do a memory heap. With this way, I'm going to just put sheets of paper with numbers on them, whether you can see them or not. This is my memory heap on the floor. Okay, so I have a memory right there. That's my memory heap. Okay, and now I'm going to get some. This is called Quipu. I bought it on Amazon. It has a book that comes with it. It tells you all kinds of things you can do with it. But you can make a memory heap, and these are make great pointers. Okay. So, and you can see they're dangling pointers, so that if you don't get the memory, you can see there's no memory attached to them. Okay, so you have to go to your memory heap, and you have to say new. I know I have some memory. How's that? Okay. The only problem is it's very sticky in the heat of India that it doesn't seem to work as well, but it worked. Okay. So anyway, that's called Quipu. It makes great dangling pointers. All right. Okay, next slide. Okay, so this is actually from the book Quipu. They have this example of a game called Paper Fetch, which just happens to be, if you next, I would actually, go ahead. Next slide. Yeah, so I would not call it paper fetch. I would actually call it, next slide, memory heap, okay? But they actually have a game described where you put the paper on the floor and you go for it. So it's actually described in the book. They just didn't call it memory heap. Okay, next slide. Okay, so then another thing you can do is cards. So I actually have, I got a jumbo deck, but I don't know if it works as well in this room. But you can maybe you can see these big cards here. Okay, so maybe it works a little better if the room's not quite so big. But you can do things with all kinds of things with cards. You can do insertion sort, because insertion sort is essentially like you have a few cards, and then you take the next one and you insert it into what you have here. 10 goes after 9, and so on. So you can demo insertion sort with cards. You can do a lot of things with cards. You can look at shuffling, dealing cards, writing classes with cards, poker hands, full house, flush, etc. And then recently, I got this idea to make women in computing more visible. So I actually created a deck of cards of notable women in computing. And so this is actually a full house if you're playing poker. And if you go to the next slide, here's the royal flush that has the 3 women who are Turing Award winners in the middle. All right, next slide. And there's the link for that. So we have the cards there. We've made them available for people. There's also, if you go to the next slide, there's a poster of the cards, and the file is available if you want to print it. It's available there. And these have lots of women that are notable for historical reasons or other reasons. We have the ENIAC programmers, and some ACM fellows, all different kinds of women. We got 54 women in there. They're very notable. Okay, next slide. All right, so then I have just a few more things here. You can do a lot of group activities. If you go to the next slide. CS Unplugged is a website. If you just Google CS Unplugged, they have a lot of activities, especially for kids, but you can also do some of these activities in your classes where students actually act out algorithms. You don't need a computer for any of the activities. So if you go to the next slide. So this is middle school students that came by Duke, and they wanted me to do something with them, so I said, great, we'll sort you. So I gave them each a number, and they're holding the numbers, and whoops, go back. I gave them each a number, Yeah, you can play the video. And they're actually, I explained bubble sort, and they're trying to sort themselves with bubble sort. So I said you can compare the person next to you and swap if you need Okay. All right, so they sort themselves. So they did kind of a parallel bubble sort, but I kind of explained you can only compare the person right beside you, and if you you can swap if you're in the wrong order, and so that's what they were kind of doing. But they were kind of getting the feel for what bubble sort is and how many swaps are involved. Okay, next slide. Okay, so I'm just about done. I was just going to spend the last minute talking about edible CS. All right, next slide. So I also have this hobby where I like to make cakes. So this is Lily in the purple plastic purse on the left there. That is a children's story about a mouse. And that cake's really big because it's my son's whole first grade class. My kids like Pokemon, if you've heard of Pokemon. Okay, that's Charizard, I guess. And this cake down here is Wiggles, or an Australian children's band. If anybody's heard of those? Okay. So there's 4 characters. They all wear different color primary shirts. And I like this picture especially, because if you do the next slide, this is actually one of my cakes that's been published in a magazine, the Wiggles magazine, issue number 42, where you basically do a cake for your kid and you send in the picture and they might publish it or not. So I put that on my CV, and if you look at my CV, you'll see it on there. I have a published cake on my CV. I think I'm the only computer scientist that has a publication with a cake picture. Okay, next slide. And so how do I make all these cakes? I have a lot of different pans of different sizes. So for example, I just figure out the shape, which is a lot of fun. And then once I've got the shape, then I'll ice the cake. So this is my son's birthday cake, Mega Man, and the bionic fish. I said, Mom, you also have to have a bionic fish there. So that's a little thing up there. Okay, next slide. All right, so what happens when your hobby and your career collide? Okay, next. It's now time for engaging students with edible CS. All right, next slide. So this is a Turing machine made out of blueberry muffins. Okay? And so what I would do is I would come into class early and I would set up a Turing machine or a finite state machine, and there's something wrong with it. Okay, so it's supposed to be the language f of x is 2x for a Turing machine, but it's not correct. So they would actually have to figure out what's wrong with it. And then once they would tell me how to fix it, they got to eat it. So this Turing machine is no longer with us. Okay, next slide. So then I got kind of tired of coming to class early and setting up these big things. So now I actually just give my students a problem, and I bring in either cookies or muffins and icing bags, and they have to build the machine. So this is students building a DFA for a problem, and that's actually their DFA that they came up with. And also, a lot of them have never used icing bags where you squeeze out the icing. So that's also a good experience for them. It's also a good icebreaker early in the semester. And again, once they have it correct, they get to eat it. Okay, next slide. This is a red black tree made out of cookies that I made a while back in my data structures class. Next slide. So you saw the middle school students sorting with these pieces of paper with numbers. Well, I had 100 students in my CS1 course, so I made a lot of cookies with numbers. And we talked about one day all these different sorting algorithms. And so I'd get 10 people to come up because it was a big class. They would each pick a cookie out of the box, and they would hold the cookie up there. And then they would have to do, say, insertion sort or selection sort or whatever sorting algorithm. And then they got to eat the cookies. And we had another group of students to do a different algorithm. And so even if you have a large class, you can still do some activities, and you have a subset of students doing the activities in class. All right, next slide. So there are lots of other things. I did this in my discrete math class. This is a graph, and it's dual graph made out of cookies. Right, next. And if I don't know if you've heard of the stacking pancakes problem, this is a problem that Bill Gates actually worked on when he was an undergraduate. And it's basically you have a stack of pancakes of different sizes, and you want them in this order from smallest to tall to largest, but they're not in that order. So you actually take a spatula and you stick it in there somewhere, and then you flip everything, and they flip over. And you want to know what's the minimum number of flips to get the pancakes in the order. So these are with cookies, so we could experiment with that. And then eat the cookies. All right, next. Okay, and then I also, these are just for fun, I make Alice cookies. They're really easy to make. You just print the picture, and then you cut out the shape, and you roll out the dough, and you put the picture on there, you just cut it out with a knife, and you just decorate them. You too can do that. Next slide. Just more Alice cookies. I usually have a lot to do at the Alice class. All right, and one more. Okay, so that's my last slide. If you have questions, I'd be happy to answer questions. Yeah, okay. I haven't figured out how to visualize complexity yet. I'm thinking about it. So most of the stuff I've done is more automata theory and grammars. We do pumping lemma. We have a tool that allows you to experiment pumping lemma, but that was a very difficult tool to do. So it's mostly canned examples that you then go through, and you actually play a game, and you pick each. You pick one, the opponent picks one, so you sort of do that. But that's actually in J-flat. But complexity theory, I haven't figured out how to visualize yet. But we're thinking about it. Okay, so you asked a question. So let's see. Anybody that asks a question gets something. Let's see. You can have a J-flat frisbee. Okay. Anybody else want to ask a question? I didn't bring any cookies with me. Sorry. Okay. I have to hear you first. Okay. I think he has a mic. He's coming. Okay. Mike is coming. Okay, so she asked a question on Scratch. Yeah, Scratch is similar to Alice. It's 2D. Alice is 3D. It also is very, it has a drag and drop interface, so they're similar. I've also used Scratch for some things. Yeah. Sorry, what?
We had a workshop about student ACM chapter where they taught high school students like standard 6, 5th and 6th on how to beginning an introduction to programming using Scratch. So that was really nice.
Yeah. So I encourage you, especially undergrads here, if you can do outreach activities to people in high schools and middle schools and try and get them excited about computer science. You can use Alice, Scratch. There's a lot of tools that are drag and drop tools that you can use with students to try and show them that computer science is more than just PowerPoint. There you go. Okay. Oh, sorry. All right, you had a question?
Do you give baking classes?
What? Do I take baking? Do I teach baking classes? No, but I have had somebody ask me. I have a website with all my cakes on it.
No, I mean you should.
Well, no, but I actually had someone email me and ask me if I would make a cake for their kid and mail it to them, and I'm not sure what the cake would look like when it got there, so I said no. But I gave them the instructions so they could make the cake for their kid.
On a more serious note, if we have workshop and stuff like that in college, and maybe if we had something like this, could you do a screencast?
Oh, could I do a screencast? Possibly, but I can't do it for everybody.
No, I mean just one. Like, if we have an event, we have theory of computation, and the computer department uses JFlap as a tool.
Oh, I see. Okay.
So
okay.
if you could do a screencast sometime, that would be really cool.
Yeah. Okay. I can't promise, but I might be able to. If everybody asks me, I can't do it for everybody, but I might be able to do it. Yeah. So you could contact me and see. Okay. And come get a frisbee if you want. Okay. All right. I can't throw it that far. You have to come get it. Okay, other questions?
I request Professor Mukul Madhavan to present a memento to Dr. Suzanne.
Thank you.
Thank you. Yes, sir.
Sorry.
So we have come to the end of the formal function, and we'll have a very short closing ceremony. I request Dr. Srinivas Padmanabhuni to come up on stage, and we are going to call some more people. After the closing ceremony, there will be a entertainment program, cultural entertainment program, which will be performed specially by Goa University students. So I request you to wait for the program. We were helped by a lot of individuals in organizing this event, and I think there were many months of preparations which went into this. And we would like to make mention of some special people who helped us from ACM India as well as from Goa and both the host institutes. I request Dr. Srinivas Padmanabhuni to present a memento to Dr. Shaila Anand, ACM Women Chair. I request Shekhar also to come up on stage. Mr. Shekhar Sasrubudde, Chief Executive of ACM. Thank you, madam. Mr. Shekhar Sasrubudde is the backbone of all these events, and whenever we had any problems, we had to contact him. And here also you must have seen everybody is consulting him, and this is our token of love on behalf of organizing institutes. Among the organizing institute, we had a big committee. There were a lot of individuals which were part of the organization, but I would like to make a special mention of very few individuals, and one among them is Professor Bhaskar from BITS Pilani Goa campus. Bhaskar, please come up. Yeah. He was mainly our one-point contact in BITS Pilani along with Professor Deshpande. So I would also like to invite Professor Deshpande and Professor Srijit. Is there? Srijit is there? Okay. Okay. So Professor Bharat Deshpande, Head of Computer Science Department of BITS Pilani Goa campus. Another co-host of this event was Goa University, and I request Professor Vivek. Yeah, Srijit is here. Yeah, Srijit. On behalf of Goa University, I request Professor Vivek Kamath, who is Vice Chair of ACM Goa and Chair of Organizing Committee of ACM annual event. And finally, I would like to call the person who was behind all this event, Ms. Maria D'Souza, Chair of ACM Goa, who has worked day and night to make this event a success. Would you like to say something? Then I'll Thank you.
So Ramrao himself deserves one.
Thank you. Thank you, sir. Yeah.
Any faculty members in the audience requested to attend tomorrow's session.
So tomorrow's session is beginning at 9:30 to 1. So there'll be a keynote address again by Professor Susan, followed by a panel discussion, and all faculty members from Goa and our other guests are requested to attend the event. Bhaskar? Here. Yeah, so it will be here itself. On behalf of ACM Goa chapter and the organizing committee of ACM annual event, I propose a formal vote of thanks because we have to thank a lot of other individuals who are part of this. First of all, I would like to thank all the speakers, guests, and a special thanks to Director BITS, K.E. Raman, who were part of the inaugural function and all the other sessions. We thank all the reviewers or IRIs, then the judges for different contests, various session chairs who chaired the various sessions. A special thanks goes to all the participants of employers presentations who came all the way from various places and conducted interesting employers presentations, rather maybe for the first time for IRIS yesterday. We thank all the IRIS presenters and poster participants. We also thank for the special opportunity given to us to launch India 6 CSE to 6 CH chair and other office bearers. A special thank goes to all the sponsors of ACM India. Without their support, we could not have organized this event. We thank ACM council members, the chapter representative who came here, all the student chapter representatives for their presence. A very big thank you to ACM chair, Dr. Srinivas Padmanabhani, for solidly being behind us. Shekhar Sasrude, who we already seen again here, and ACM W chair, Dr. Sheila Anand. We thank all the delegates, faculty members who came from various colleges. And special thanks goes to all the students who came from various institutes from Goa to attend this function in a large number. I also thank all the hotels, the travel providers, caterer, and all other services which were provided to us by various agencies. A special thank goes to also media. A big thank you to BITS, Pilani, Goa, KK Birla Goa campus for providing this venue and providing all the facilities, and Goa University for providing all the other support. And I would be failing in my duty if I do not thank the tremendous work which was put by our student volunteers from Goa University and BITS Pilani Goa campus. And I request all of you to join your hands and say thanks to them. So we come to the end of this formal function, and within short time there will be a cultural event which will be organized over here by Goa University students. I would request you to be a part of it, and that will be followed by a dinner. And again, see you tomorrow for the 6 CSE event. Thank you.